So what we're looking at here in finishing up, us going back over chapter 7, is solving these here. Now the first few ones we look at, when we saw it in the textbooks, they referenced this as cross multiplying. And I have a feeling at some point you've covered cross multiplying before, because we cross and then multiply them together. And this works for these here, or any type of proportion works out well. But once we get more than one term on either side, it completely falls apart. And I've never seen the point of going over a method, kind of like cross multiplying, which works as long as I only have one set of fraction on each side, and any other setup doesn't work. I don't see the point in that. Because it does work nicely here, and once we get to ones that have more than one term on either side, it completely falls apart. So then we have to go over a completely different way to cover those. But using least common denominator, essentially what we did for our complex fractions to get the fractions in the top and bottom to cancel, works out well for this here. So what we do at the start, and some of them it's not going to make too big of a difference, we do need to see what the restrictions are. What value of x cannot be? And here, do we know what it would be? Well, sometimes it's a little bit harder to see it than others. So we're trying to see what value of x is going to make 3x minus 1 be 0. Well, we can start off by adding 1 to both sides, which tells us that 3x is equal to 1. And then we would divide by 3, telling us that x is 1/3. So x cannot be 1/3, because if x is 1/3, then it doesn't work. And that's kind of nice to have, because if we solve this out here and get that x is 1/3, we know that that solution is not true. It does not work. All right. Now we need to simplify the denominators. We need to see what do we multiply each of these expressions by to get the denominators to simplify. We know one of the numbers would be what? 4. Yeah, we'll need to multiply everything by 4. What else? The 3x minus 1. Because we need all the denominators to simplify. So we need the 4 for the 3 over 4, and the 3x minus 1 for the 3x minus 1. And when we do this here, well, the 3x minus 1 and 3x minus 1 will cancel. Over here, the 4 and 4 will cancel, leaving us, well, in the first one, it would be 6 times 4 is equal to 3 times 3x minus 1. Now, if you wanted to, we could have gone on and multiplied these. If you felt comfortable at this point here to do 6 times 4 and get 24, you could have done that. You didn't have to rewrite out 6 times 4. We could have also done 3 times 3x, which is 9x minus 3. So I could have gone from this step and jumped straight down to this here. Because if you feel comfortable doing those multiplication, doing that distributive property, that's perfectly fine. But it is nice if you have a feeling you're probably going to drop a sign somewhere or lose a term or kind of mix a term up, to go on and just write it out. Because you won't lose any points for writing each step out, but if we lose something or put the wrong sign or wrong number, well, we'll end up getting the wrong answer. Well, now we just need to solve for the value of x. Well, first thing we could do is add 3 to both sides, which will tell us that 27 is equal to 9x. divide both sides by 9, which will tell us that x is equal to 3. And is 3 one of our restrictions? Nope. So, okay, that solution works just fine. Any questions on any of this here? All right, let's look at the next one. 5 over x is equal to 7 over x minus 4. So again, this here, it's good to see what the restrictions are, just in case that there are any that pop up. Well, with x by itself in the first denominator, we know x cannot be what? 0. Because if I wanted to, I could set that equal to 0 and then solve for the value of x. Okay, it's already by itself. So x is 0. Our other one that we have is x minus 4. Well, that would be 4. And we could set that up as x minus 4 is equal to 0. Solve by adding 4 to both sides, telling us x is equal to 4. So neither one of these will work. So if we get a solution that is either 0 or 4, we know that that solution is an extraneous solution, and it does not work in the original equation. Okay. So what do we need to multiply each one of these terms by? X and x minus 4 times x minus 4. In our first term, the one on the left, well, the x and x would cancel out. In the other term, the x minus 4 and x minus 4 would cancel. So this is gone, so we just have 5 times is equal to 7x. If you wanted to, you could have gone on and multiplied the 5 times x minus 4. Well, 5 times x is 5x, and 5 times negative 4 would give us negative 20, or minus 20 is equal to 7x. Now at this point here, we can get x by itself by subtracting 5x from both sides, which would tell us that negative 20 is equal to 2x. And last but not least, we would divide by 2, telling us that x is x is equal to negative 10. And that's it. And is negative 10 one of our restrictions? Well, no. So that's it. That's all we have to do on these here. Any questions on any of this here? All right, let's look at one more of these here and then we'll move on, because I have a feeling that we don't need to do too many more of these here. So looking at this one here, let's name the restrictions first. So what can x not be? Negative 1 or negative 7. Because negative 1 would make the x plus 1 be 0. The negative 7 would make the x plus 7 be 0. Okay, what can we do next? Times what? Right, we need to multiply all the terms in the equation by x plus 7 and x plus 1. Because doing this, we'll get the denominators to simplify. In the first one, the x plus 1 and x plus 1 would cancel out. And the other one, the x plus 7 and x plus 7 would cancel out. Now, if you wanted to go on and multiply them together, you can, or we can rewrite them back out. Our x plus 3 times x plus 7 is equal to 15 times x plus 1. For some of y'all, doing the 15 times x plus 1 is not too bad, because we can do 15 times x, which would give us 15x. Plus 15 times 1 is 15. So if you felt comfortable with doing that, you don't necessarily have to rewrite it. You can if you want to. But I have a feeling most likely that most of y'all are not as comfortable doing the x plus 3 times x plus 7 all in one step without having to write out a little bit. Because if you could say, okay, I see that I have x plus 3 times x plus 7, and okay, that's going to give me x squared plus 10x plus 21. Okay, you can do that, but if you're not as comfortable doing that all at once in your head, go on and write it out. Because our x times x gives us x squared. X times 7 would be our 7x. 3 times x would be plus 3x, and 3 times 7 is 21. Then our 7x and 3x would combine to give us x squared plus 10x plus 21 is equal to 15x plus 15. So if you could have gotten there, awesome. If not, that's perfectly fine too. Because writing the steps out does help us to get where we need to be and does decrease the likelihood of us dropping a term or having a calculation error. Now we need to get everything on the same side of the equation because since we have a quadratic and x squared term, we do need this equal to 0. So at this point here, we can subtract 15x from both sides, which will tell us that we have x squared. 10x minus 15x is negative 5x plus 21 is equal to 15. And at this point here, we can subtract 15 from both sides. I'll scroll back down, which will tell us that we have x squared minus 5x plus 6 is equal to 0. Now we just need to solve for the value of x. One of the ways that we've really not been using too much is the quadratic formula. Really, we've used it only if we absolutely had to, where the solutions didn't give us rational numbers. The main way we've been doing is factoring, but there is one method we've actually forgotten about, which is graphing it. Because if it is factorable, most likely it's going to be graphable. So I can go into y equals, I'll clear that out, and say x squared, so here it was minus 5x plus 6, and graph it. Okay. It does cross the graph in two places. If I go second graph, I'm trying to see what value of x is going to make the y value be 0. Well, okay, there are two of them at 2 and 3. Bless you. So what that tells me is that the solution for this here is that x is equal to 2 and x is equal to 3. And interestingly enough, if we had factored this, we would have gotten x minus 2 times x minus 3 is equal to 0. And whenever we multiply two things together and it equals 0, one of them must be 0. So we can say x minus 2 is equal to 0, and x minus 3 is 0. Well, then we would just solve for the value of x. adding 2 to both sides here, adding 3 to both sides here, while telling us that x is equal to 2 and x is equal to 3, the exact same things we got. Questions on this here? Graphing gets a little bit more tricky, especially if we have fractions, and especially if the fractions are not rational. We don't have a non-repeating, non-terminating decimal. It'll kind of give us something a little weird. And really, if there's a term in front of x squared, most likely we're going to get fractions. Most likely we're going to get fractional answers. Any questions on any of these here so far? All right. Let's skip that one and go on to this one here where we have some with multi-terms. Let's find the restrictions first. So we're trying to see what value y cannot be. 4 and 3. Because 4 is going to make the y minus 4 be 0 in the denominator. The y minus 3 is going to make that denominator 0. So it can't be either one of these here. Okay, we found those. Now our next step is to do what? Multiply each one by y minus 4 and y minus 3. With green this time. And if we do this, we will have some simplifications in each one. In the first one, the y minus 4 and y minus 4 will cancel. In the middle one, the y minus 3 and y minus 3 will cancel. And well, since the last one is just the number 1, it doesn't have a denominator, nothing's going to simplify out. So we can see what we have left. Well, in the first one, we have 4 times y minus 3. And you could go on and multiply that out and say 4y minus 16. But if not, we can always rewrite it out. Minus 3 times y minus 4 is equal to y minus 4 times y minus 3. Now on this one here, we need to be careful, especially if you went on and multiplied it out, because the middle set of terms is not going to be negative 3y minus 12. Because that's one place that you can have issues, or issues do pop up, and I've seen it before, especially with setups like this. Because here, you're very tempted to multiply the y minus 4 by the 3. But is that 3 actually a 3? It's not another number, it's not just 3, it's what? Negative 3. Because the minus is attached with that 3. So that it's very possible that when you do this multiplication of multiplying by the negative 3 times y, we will get, because the negative is already there. But that's not going to be a minus 4 anymore, because negative 3 times 4 is what? Plus 12. That's where an issue can come up. Because if we do it and just kind of multiplying through and not thinking about the fact that this is being minused, you'll do 3 times y, which is 3y. Well, the minus is still there from the original problem. You'll do 3 times negative 4y and write negative 12. But it's not really negative 12 because we are having that 3 as a negative. Y'all kind of see that? And that's some of the times why rewriting it out is helpful, so that we don't lose that sign change. Here we can multiply by 4 and get 4y minus 6. It's not 16. I was so focused on the middle, I rewrote it as a 4 and not a 3. I'm glad I caught that. I have a feeling some of y'all caught that too, but just assumed that some math magic happened and it turned into a 4. Now, we do need to multiply the other side. Well, our y times y gives us y squared. Y times negative 3 is negative 3y. Negative 4 times y is negative 4y. And negative 4 times negative 3 is plus 12. The left-hand side of this is actually kind of nice. When we combine like terms, 4y minus 3y is 1. Negative 12 plus 12, we just get y. On the other side, we'll have y squared minus 7y plus 12. Now, what do we need to do next? Get this thing equal to 0, so we would subtract y from both sides. To give us that 0 is equal to y squared minus 8y plus 12. Now, especially on the ACT, if you got to this point here, if you feel very comfortable with factoring and can do it pretty quickly, go on and factor and solve. If you feel more comfortable or you can graph it faster than you could factor this, go on and graph the thing. Now, looking at it, we know one thing: there won't be fractions if there are solutions, because the term in front of y squared is 1. There's not going to be a division. So whatever the solutions are, most likely they are actually factors of 12. And it turns out they are. Because if we'd have factored this, well, the 12 tells me that the signs are the same, so they'd both be negative inside the factors. Factors of y squared are y and y. Now we need to find the factors of 12. 2 and 6. Two things multiply together that equal 0, yes? So one of them must be 0. So looking at this here, can y'all tell me what the two values are going to be? 2 and 6, yes? I find this kind of funny, and I mentioned this first hour, that I actually do write this out and solve it here, but we don't do it at the start. Is this any different than finding the restrictions? No, it's actually the exact same thing. Two and 6. Neither one of those is our restrictions, correct? Well, no, so those are our answers, yes? So that's it. Now on the ACT, well, it's been noticed upon for those of you who have me for ACT prep, and if you have Ms. Kendall for the other one, that really you need to save every bit of time that you can from problem to problem, yes? If you got to this point here and can see, okay, it's 2 and 6, pick the answer and move on. Is there any real reason for me to actually solve it by hand? No. That saves you a few seconds there, especially if that ends up happening 5 times over the test and it saves you 2 to 3 seconds. That's 10 to 15 seconds that you have for other problems. Or heck, if you could have graphed it and gotten there even faster, even more time. Because they are not going to actually go through and check your work. They're just going to look at your Scantron. Are there any questions on this here? Any questions over anything we've done so far? And we'll look at the next one, but on an ACT, something like this here, I would subtract the 1, get this thing equal to 0, and graph it. Because if it gives me whole number solutions, and I will know if it does, because it gives you 5 answer choices, doesn't it, on the ACT? If all 5 of them are whole numbers, get this thing equal to 0, graph it, see where does it cross the x-axis. Those are your solutions. Even though it doesn't give us in terms of x, is there anything wrong with turning this into x and x? No, it's just a variable. And we can solve it that way by graphing. Okay. This here, we'll finish off with this one here, and then I'll give you the rest of the time to work on any of the assignments. And we'll go through and work through how to solve this. And realistically, like I just said on the ACT, I would get this thing equal to 0 and graph it. As if the solutions are whole numbers, that'll give it to me, or at least get me close enough to the solutions to be able to figure out what they are. But here, we're going to go on and see how we would solve this by hand, or actually work it out. Now this one here, it's very tempting, because we'll look at restrictions here in a second, to say that I need to multiply each one of these by x, x plus 1, and x squared plus x. It's very tempting to say that. And it would work. It would make solving it a lot harder at the end, but that would work. And the issue comes in with the middle term. Now we can see that x and x plus 1 are in simplified form. X plus 1's degree is 1. X's degree is 1, and there's no greatest common factor between those for x plus 1 or x. However, the middle term, the x squared plus x, does have a greatest common factor of x. Okay. And if I factor that out, I get x times x plus 1. Well, so multiplying, as we said, by x times x plus 1, x times x plus 1. Doing this here, would I need that x squared plus x to be multiplied through? Well, no, because the middle term is what? X plus 1, yes? So adding that in, that x squared plus x, is increasing the degree of what we would have. So if the degree, all the x's that we have once we do this, if the highest variable is 1, well, I've actually added 2 x's into it. So instead of having a degree 1, it would now be a degree 3. We'd have to solve a cubic. Each variable we add in when we multiply across over what we need is taking the degree of the biggest exponent that we have and increasing it by 1 for each one that we have. And the solutions that it adds are actually the restrictions. So it makes it harder to work, and it gives us answers that actually aren't going to work anyways. It doesn't do us any good. And our restrictions for this here are going to be, well, 0 and -1. It actually works out if we'd added the x squared plus x, on top of the answer we would get, we would also get 0 and -1 as solutions, which is not something that we want. Because if we can keep this simpler, I'd want to keep it simpler, because if it comes out where it's just a linear equation, or I just have to get x by itself and everything on the other side, that'd be nice. Well, here, the x plus 1 and x plus 1 would cancel. Here, the x times x plus 1 would cancel with the x times x plus 1. Over here, the x and x would cancel. So let's see what it simplifies to. The first term is going to be -1 is equal to 3 times x plus 1. Or if you'd gone on and multiplied that out to 3x plus 3, that's perfectly fine. You don't have to write it with the parentheses, especially if you feel comfortable doing that. So here, when we multiply through, we get that 2x minus 1 is equal to 3x plus 3. Well, so we have a degree 1. The biggest exponent with the variables is 1, yes? If we'd have multiplied through everything by the x squared plus x, It wouldn't be 1, it would be 3. We would actually be dealing with a cubic. That's a lot harder or unnecessary than we need, so not multiplying by this is helpful. Well, what do we need to do to solve for the value of x? There are going to be two things. One of them is subtracting 2x from both sides. Which will tell us that -1. Yeah, you can do both of them. Because we could have done the subtracting of 2x and the subtracting of 3 all at once, telling me that x is equal to -4 and gotten the answer. And I was actually going to, that's not bad, no, that's fine. Because now we just need to subtract it over. Yeah. Yeah, and actually if we wanted to, we could have graphed that and see where it crosses the x-axis and it'd be at -4. And the reason we don't normally do that is, well, it's just as easy to move it over as it is to graph it. So we don't really save any time. And is that one of our restrictions? Well, no. If it was, we would just mark it out. Are there any other questions on any of these here? Do we feel comfortable with these here? A lot more comfortable than last time. Yes? And that's all we have to do for any of these. It's just working these through, and especially making sure we have the correct thing to multiply through. Any questions on any of this here? No? Okay. But that's all we're going to look at here, because I do have a lot more in here that we could look at and do, but it's really not adding anything more than what we already have. If you do work through them and want to find out what the answers are, you can ask me and I'll work it out and either give it to you or kind of check your answers and make sure you got them right. But that's it. Now, the homework is a worksheet over this here.